Welcome back, learners. Now let us quickly look at the more exam questions. Right, let's look at another multiple choice question. I thought that was the last one. Now, it says to us, which one of the following pairs represents the conjugate acid and the conjugate basis of HPO4 2 minus? All right. Right, I've already said to you here, the answer here is B. Why is the answer B? Because the conjugate acid base pair, you need to have HSO4 minus as your acid, and then your PO4 3 minus as your conjugate base. All right, so that is the correct answer. Let's quickly look at 1.8. It says, which one of the following indicates the correct color of bromothiamyl blue in an acid or in an acid and a base rather? Let's check. Remember, what did I say about the different colors? You see how the tip now is coming in terms of the colors. The correct answer there will be D, because in an acid, the bromothiamyl blue is going to be yellow. In a base, it is going to turn what? Blue. All right, so that is the correct answer. Now let's quickly move on to more exam questions. Now we are looking at structured questions, okay? The way the examiner might structure the question. Now, let's look at 8.1. It says two reactions of sulfuric acid are shown in the diagram below. There you have it. Here you have reaction 1 and you also have reaction 2. Now, before you can go to any question, it is important and advisable that you interpret the flow diagram that you are given, and look at where the arrows are indicating. Then you'll be able to see what is going on. Let's quickly look at reaction 1. For me, reaction 1 says that I have reacted a sulfuric acid, which is H2SO4. So that will be H2SO4 that has reacted with what? With sodium hydroxide, which is NaOH. All right. The results are going to give me a salt plus product Y. So what is the salt? The salt that will be formed will be Na2SO4 plus what? Water. So this will be the correct chemical reaction that happens there. Let's see if we can balance the equation. How many hydrogens do I have this side? I have 2 plus 1 is 3. This side I have 2. So to balance the equation, I can put a 2 over here and a 2 over here. Then the equation will be balanced. Let's check how many hydrogens will I have. I have 2 plus 2, it will be 4. And then 2 times 2 will be 4. Sulfur 1, sodium 2 and sodium 2 over there, and then oxygen is 4 plus 1, plus 2 rather, which is 6, and then that is 2 plus 4 will be 6. So the equation is balanced. So that is the first thing that you do before you try to attempt to do anything. Now, this has told me that the reaction is salt plus compound Y. I already know that if my product is a salt, that means I am dealing with a neutralization reaction. I hope we are still together there. Let's quickly look at reaction 2. Reaction 2, I still have sulfuric acid, which is H2SO4, that now reacts with water to form an amphorite plus H3O plus. So if I put it in an equation, how is it going to look like? Okay, there are different ways in which it could look like. Because they want to see an amphorite, it might be that we want to see step 1 or step 2, but we know that if we are dealing with H2SO4, we are actually dealing with a strong acid, which will do what? Which will analyze, which will ionize completely in water. All right, according to the following steps. So I'm going to indicate step 1 of reaction 2, which will be H2SO4, okay, that is going to react with water, and my product will be what? Hydrogen will donate, H2SO4 will donate a hydrogen to water for the product to be HSO4 minus plus H3O plus. All right, that is the first step. The second step of complete ionization of sulfuric acid, it will be HSO4 minus, that is going to react with H2O again. What will happen here? the last hydrogen that is remaining is going to donate a hydrogen to water and then to form what we call SO4 2 minus. That 2 minus indicates that now H2SO4 has donated all the hydrogens, all right, plus H3O plus. Okay, so I just wanted to write it down. Before I can go to any questions, I must interpret this question like this so that you will see it will be easier for me to answer the questions. Let's go to 8.1.1. It says define a Lowry-Bronsted base. Remember, guys, it's very important to differentiate, to know the two definitions according to Arrhenius, according to Lowry. Okay, Lowry-Bronsted is saying that a base is a proton acceptor. So we will say here a proton acceptor. A base is a proton acceptor. Remember that, okay? And then you get just 2 marks for just saying that a base is a proton acceptor. So can you see how important it is to know our definitions? And we said that one of the structure of this question is that there will always be definitions. Now, let's quickly look at 1.2. It says, write down a balanced equation for reaction 1. Guys, I've already done reaction 1 when I was interpreting the diagram. So can you see that now it becomes easy? I will just do a copy and paste. So what will be the reaction 1? I've indicated it over there, which is going to be H2SO4, SO4 is going to react with NaOH, which is a strong base, to give us salt, which is Na2SO4 plus 2H2O. So remember that the equation needs to be balanced, right? I've already done that for you. And then the next question, 8.1.3, was saying to us, write down the name of the salt represented by X. Remember the question now, the examiner says to us, we must write down the name. It's very important. The examiner indicated the word name in capital letters, which means that they really need the name of this salt, not the formula, okay? We know the formula is Na2SO4. So what will be the correct name? The correct name will be sodium sulfate. So the correct name is sodium sulfate. All right, I hope you guys got it correct and you guys know how to deal with this one. Let's quickly move on to 1.4. It says to us, write down the formula. Now we are looking for the formula of an ampholyte A. Remember, an ampholyte, it is the substance that can act either as an acid in the presence of a base or act as a base in the presence of an acid. I hope you still remember the definition of an ampholyte. Right, as I've indicated 2 equations, step 1 as well as step 2. Why did I indicate them like that? I wanted you to see clearly which one will be the ampholyte. Guys, you can quickly check by yourself. Quickly check for reaction 1 and reaction 2. Which one do you think is an ampholyte? Which one acts as a base in the presence of an acid and acts as an acid in the presence of a base? Okay, so I hope you guys got it correct. The correct answer, yes, well done, is HSO4 minus. HSO4 minus is an ampholyte because in reaction 1, H2SO4 is an acid and then HSO4 minus is the conjugate base. And then the same conjugate base now becomes an acid to donate the hydrogen to water. That's why we are saying HSO4 minus is an ampholyte, because in reaction 1, step 1, it's acting as a base, and in step 2, it is acting as an acid. I hope you guys got it correct over there. Now, let's quickly move on to 1.5. 1.5 says to us, write down the formula of the 2 conjugate acid pairs in reaction 2. So now our focus is reaction 2. They want to know the 2 conjugate acid base pairs. Okay, so the first pair is going to be the pair between H2SO4 and what? And HSO4 minus, because as we have seen, the HSO4 is an acid because it has donated, okay? And then HSO4 minus becomes the conjugate base, okay? That is the first pair. The second pair, it is the pair between HSO4, H2O and H3O, okay? H3O plus. So the second pair will be the reaction between H2O, which is acting as a base in reaction 1, because it is receiving the hydrogen from sulfuric acid, which is H2SO4. And then the conjugate, the base will then form a conjugate acid, which is H3O plus. Right, these are the two conjugate acid-base pairs in reaction 2 that you need to know, because according to this, that is the reaction that we are looking at. Right, I hope you guys also got it correct. Here are my answers. I hope you got it correct. Please give your marks where they are due. If you gave us that the base is a proton acceptor, please give yourself 2 marks. This one is either 2 marks or nothing. If you wrote down the correct balance equation, okay, and then you also indicated which ones are the product and which ones are the reactant, please give yourself the 3 marks. So 1 mark is for the reactant and the other mark is for the product, and the last mark is for making sure that your formula is balanced. Then for writing sodium sulfate, remember the question was asking for the name, not the formula. You get 2 marks for that one. For indicating the ampholyte A in the reaction there, you get the 2 marks for identifying the ampholyte. We said it's HSO4 minus because it can act as an acid and also act as a base. Then we said the 2 pairs of the conjugate acid-base pairs are those, and I hope you guys got the correct answers. 5.1 says to us, define an acid in terms of Lowry-Bronsted theory. Can you see that this thing of a definition, you can't run away from it, guys. You need to know the definition. I'm sure you already know the answer to this one. Yes, the answer is a proton donor. An acid is a proton donor according to Lowry, and then a base is a proton acceptor. I'm not going to write that because I don't have much space. And then we go to 5.2. It says to us, carbonate water is an aqueous solution of carbonic acid. There is our carbonic acid, which is H2CO3. H2CO3 ionizes in 2 steps when it is dissolving in water. It's true, it has to ionize in 2 steps. And then let us see if we can answer the questions. 5.2.1 says, write down the formula of the conjugate base of H2 CO3. Now, because it has ionized in 2 steps, that means that it has ionized completely in water, okay? Meaning the first step, it will give away the hydrogen, and then you will have the conjugate base as HCO3 minus, and then the second step, you'll be removing the other hydrogen, and then your conjugate base will be CO3 2 minus. Why are we writing CO3 2 minus? Because they indicated to us that H2CO3 ionizes according to 2 steps. That means that it ionizes completely in aqueous solution. 5.2.2 says to us, write down a balanced equation for the first step in the ionization of carbonic acid. They want to see the first step, okay? They don't want to see 2 steps, they only want to see 1. So what is the first step? It is carbonic acid, which is H2CO3, okay? That is going to react with water, okay? Because remember, it is in aqueous solution. Remember that. Ionizes completely in aqueous solution. H2CO3 reacts with water, and our product will be hydrogen will be donated to H2O, which makes H2SO4 and SO3 an acid, which makes H2O a what? A base. So what will be your product? It will be CO3 minus rather plus H3O plus, because the H2O has added or received rather or accepted rather a what? A hydrogen. And that is how the equation is going to look like, and this is already a balanced equation. Let's quickly move on to 5.2.3. The question says the pH of a carbonic acid at 25 degrees is 3,4. So in this question, they gave us the pH. Normally, you know, sometimes the question can say calculate the pH, but in this question, the examiner has turned things around. They want you now to either calculate the concentration of something because they've already given you the pH. And this pH is at 25 degrees Celsius. What comes into your mind? The KW formula, if you still remember it. Calculate the hydroxide ion concentration in the solution. What is it that you first need to be able to do? You need to be able to first calculate the concentration of the acid. Using which formula? You will say pH is equals to minus log. Remember the formula? The concentration of hydronium ion. There we go. Then the next thing that I'm going to do is to make my concentration the subject of the formula. I hope you still remember your logarithms for mathematics. How will this look like? I will have H3O plus will be equals to 10 to the power negative pH. I hope you remember your logarithms, which one is the base and why do we use the base of 10? When you know all the rules of the logarithm is the ones that we are going to use here. I'm looking for the concentration of H3O plus. This will be equals to 10 into the exponent. I have the pH. I'm given the pH as 3,4. That will be 3,4 over there. All right. When you quickly punch into the calculator, the concentration of hydronium ion should give you, I hope you have done it. You've done it. What is the answer? I've done it for you. The answer is 3,98 times 10 to the power negative 4 mole per decimeter cubed. All right. Remember that now I calculated the concentration, but they don't want the concentration of the acid. They are looking for the concentration of the hydroxide. So what do we do from here? We know that Kw at 25 degrees is equals to the concentration of hydronium ion H3O plus multiplied by the concentration of OH minus. All right. This formula, you don't have to memorize it. It's there on your formula sheet. What is the value of Kw at 25 degrees? It is 1 times 10 rather. 1 times 10 to the power negative 14 is equals to the concentration of hydronium. We just calculated it. We got 3,98. Then you just put the 3,98 times over here 10 to the power negative 4. And then you multiply that with the concentration of OH minus. Then as from here, what you do, you just solve for X. You are looking for the concentration of OH minus. If you have done it correctly and you have punched everything into your calculator, I hope your calculator is telling you the same answer that I'm getting. I got already, because I've done the calculation, I got 2,51 times 10 to the power negative 11 mole per decimeter cubed. Okay, that is the concentration of OH minus that I have got. So this one was a bit tricky, but not that tricky if you understood that you just had to work backwards. Remember, you were not looking for the concentration of hydronium. You were looking for the concentration of what? Of the hydroxide. That's why from getting the concentration of hydronium, we had to go back to the Kw value. Why did we use that? We were guided by the temperature to say the pH at 25 degrees, which is also equivalent to 298 Kelvin, is rather 3,4. Then we use that to get our answer. Right, I hope you guys are still with me. We quickly go to 5.3. It says to us, X is a monoprotic acid. Remember, monoprotic acid means that it can donate one hydrogen. State the meaning of the term monoprotic. I've already answered the question. I said that it is this acid that can donate one proton. All right, I hope you got that correctly. And these are the definitions that you need to know. 5.3.2 says a sample of an acid X is titrated rather with a standard sodium hydroxide solution using a suitable indicator, right? Then they say at the end point it is found that 25 centimeter cubed, or yes, 25 centimeter cubed of an acid X is neutralized by 27,5 centimeter cubed of sodium hydroxide solution of a concentration of 0.1 mole per decimeter cubed, and the question says to us, calculate the concentration of the acid X. Now here, every time, these are the keywords that we are looking for. Let me use a different color so that you can see what am I emphasizing. I am saying that in a question like titration, the moment you see the word titration, the moment you see the word neutralize, the end point, there is a formula that I said you must look at, okay? So that formula is governor. I call it governor. So it's easy to remember. Why is it called governor? You just go to your formula sheet. I'm quickly going to erase everything because I know you got these answers and you got everything correct. I just want to provide space for myself. So let's quickly now look at how are you going to do this one. I said you look at the keywords titration and then titrated, neutralized, endpoint. The moment you see that, you use the formula governor. See, a concentration of the acid multiplied by the volume of the acid is equals to the number of moles of the acid over the concentration of the base multiplied by the volume of the base over the number of moles of the base. So that is my governor. That is the one that you must think about when you think about this type of question. So what is the first thing that you are going to do? You have to collect your data. In this one, when it comes to the volume, you can see that our volumes are given with 25, centimeter cubed, and over here we are given centimeter cubed. It's not really a problem if you don't convert your volume, because whether you convert or not, it will still lead us to the same answer. So you don't have to convert. Okay, it's not really a stress when you are dealing with this formula. Only on this formula you are allowed not to convert, and only when you have the same, okay, the same SI units, then you are not allowed to convert, okay? But if you have different, if this one was decimeter cubed and this one was centimeter cubed, then you need to convert one to the other so that your volume is the same. It's either you're going to be using centimeter cubed or you'd be using decimeter cubed. I hope you're with me there. Now let's quickly collect the data and let us see what do we need to substitute over there. A sample acid X is titrated with a standard sodium hydroxide solution using a suitable indicator, and at the end point it is found that 25 centimeter cubed of an acid. So what is that 25? It is the volume of an acid. Okay, that is the volume of an acid. So under volume of the acid over there, I'm going to put the 25 over, then is neutralized by 27.5 decimeter cubed of sodium hydroxide. Remember, sodium hydroxide is a base, okay? So under the volume of the base over here, I'm going to write there 27.5, all right? And then they say to us that the sodium hydroxide has a concentration of 0.1. What is that, the 0.1? It is the concentration of a base. Then over here, I put 0.1 as the concentration of the base. And then they say to me, calculate the concentration of the acid. That means I'm looking for the concentration of the acid is equals to, because this is the monoprotic acid, it means that it can only donate one. And then if it donates one, and then it reacts with what? With sodium hydroxide. Rather, when it reacts with sodium hydroxide, then the ratio between the monoprotic acid with sodium hydroxide will be 1:1. All right, so it's 1:1 because the acid is monoprotic. It doesn't donate twice. If it was donating twice, then the ratio will be times 2 or 2 for the acid. I hope we are still together. Then guys, quickly punch that into the calculator, or you can solve mathematically. If you did it correctly, you will get your answer as 0.11 mole per decimeter cubed. All right, well done guys. I hope you guys got the same answer that I did, and I hope you guys are following. When do we use this formula? When we see titration, endpoint, neutralization. The moment they speak titration, this is the formula that you need to use. Guys, that is how we get our 5 marks. I hope we all got the correct answer. Let's go to 5.3 quickly. It says the concentration of hydronium ion in the sample of an acid X is that amount. It's 2.4 times 10 to the power negative 4 mole per decimeter cubed. Is acid X a weak or a strong acid? Explain your answer by referring to the answer in question 5.3.2. Now, this is going to be a weak acid. So the correct answer here will be weak acid. Why is it a weak acid? You can see here that in the concentration of this acid is 0.11 mole per decimeter cubed. But when you look at the concentration of the hydronium ions in the sample of the acid, it's 2.4 times 10 to the power negative 4 mole per decimeter cubed. Okay, that tells you that the concentration of the hydronium ion is actually lower than the concentration of the acid. So that is why it is called a weak acid. Why weak acid? The concentration of H3O plus, which is this one, is lower. Okay, is lower than the concentration of the acid. Okay, that is the concentration of the acid, which is 0.11. It is greater than 2.4 times 10 to the power negative 4. I hope you guys got the correct answer. Now, this is just a marking guideline on how the examiner or the markers were going to mark you when you were answering the previous questions. If you said proton donor for 5.1, you have your 2 marks for definitions. As you can see, all the definitions are worth 2 marks, and it's either is 2 marks or nothing. And please define according to the exam guideline. For including that 5.2.1, you get 1 mark for that one. 5.2.2, you get 3 marks. Remember, when you write the correct formula, it's the reactants 1 mark, the product 1 mark, and for the balanced equation you get an extra mark, and that is worth 3 marks. And then here, this is the calculations that I showed you. I said the first thing that we need to do is to convert the concentration of hydronium ions, the pH into the concentration of hydronium ions, which was 3.98 times 10 to the power negative 4. And then from there, we went to the Kw equation because we were indicated on the question that this happened under 25 degrees Celsius at a standard temperature. All right. And then we went there and then we calculated the concentration of OH, and then we landed the answer as 2.51 times 10 to the power negative 11. I hope you guys got the answers, and you can see how the ticks are evenly distributed as you answer the question. Right, guys, let us these are more of how the question you are going to be marked. I hope you can see over there. We were saying that it is a monoprotic acid. And then for 5.3.1, you can see over there an acid that donates 1 proton. You get 1 mark for that definition. Our governor equation, that is how it is. Or you can just calculate the number of moles of sodium hydroxide. You get the number of moles. But remember to convert your volume. If you decide to use this equation over here, you must remember that the volume has to be in decimeter cubed. In this formula, it is not a must that your volume must be in decimeter cubed. I hope you're okay there. Then you move from the number of moles of the acid to the number of moles of sodium hydroxide using the mole ratio, which was 1:1. Then you go to the formula C is equals to N over V to calculate the concentration of the acid based on the number of moles of the acid that you need to react with the sodium hydroxide. Then it will land us at the same answer, which is 0.11. I've already indicated here for 5.3.3 that is the correct answer, and that is how you answer the question. So the next exam question says that an hydrogenous oxalic acid is an example of an acid that can donate 2 protons and thus ionizes in 2 steps as represented in the equation below. As you can see, it ionizes in 2 steps because it has 2 hydrogens. If it has 2 hydrogens, that means it must ionize, or it must donate the 2 hydrogens in 2 steps. So as you can see, we have step 1 over there and then step 2 over there. Let's quickly look at 3.1. It says to us, write down the word for the underlined phrase in the above sentence. What is the word for the underlined phrase in the above sentence? The above underlined phrase is an acid that can donate 2 protons. What is the correct answer? Well done, guys. The correct answer is diprotic acid. So this is a diprotic acid because remember, di means 2. This means that this is the acid that can donate 2 protons. Well done, guys. 3.1.2 says to us, the formula for each of the two bases in reaction 2. So our focus, we zoom into reaction 2. We want to know which ones are the bases in reaction 2. Let's quickly check. COO2 minus is our acid, okay, and then H2O is our base over there, okay. So that HCOO2, which is oxalic acid, is going to donate a hydrogen to water, H2O, and your product will be H3O plus over there, and COO2 2 minus. So now we want to know which are the two bases in the equation. So HSO4 minus, HCO4 2 minus will form a conjugate base. This is the conjugate base, all right? And then our base will form a conjugate acid, will form an acid, okay? A conjugate acid. So now we want to know which ones are the bases. I already gave you the answer. I hope you are writing it down. So the correct answer will be H2O and what? And COO. 2 minus. So that is the correct answer. So our correct answer will be H2O is a base in the forward reaction, and then COO2 minus will be base because the H3O plus has to donate a hydrogen back to COO2 to take it back to HCOO2 minus. All right, so it's HO2 and COO2 minus. So these are the correct bases that we must know. Quickly look at 3.1.3. I hope you guys are getting it correct and you are checking yourself and marking yourself. The formula of the substance that acts as an ampholyte in reaction 1 and 2. And then the question says further give a reason for your answer. So as you can see, remember, an ampholyte is the substance that acts as an acid in the presence of a base and can act as a base in the presence of an acid. Now let's check which one acts as an acid here, the presence of a base. Right, we know that the correct answers here will be what? Will be HSO4 minus. HSO4 minus, not HSO4, rather it's HCOO2 minus. It is a conjugate base in the reaction 1, and then in reaction 2 it is a what? It is an acid. So the correct answer there is H into COO2 minus. So take note of those minuses that we put over there that indicates that it has lost a what? A hydrogen. So that is the correct answer. Why is that? Because it is an acid. It is a base rather in reaction 1, and it is acting as an acid in reaction 2. 3.2 says to us, give a reason why oxalic acid is a weak acid. So all the time when the examiner says to you, give a reason why oxalic acid is a weak acid, the examiner is actually looking for a definition of a weak acid. It is a weak acid because it ionizes or dissociates incompletely in aqueous solution. So that is why we call it a weak acid. I hope you got that correct. Let's quickly move on to 3.3. I hope you remember these definitions and you are picking up all these marks that we are getting there. A standard solution of COOH2 of concentration 0.2 mole decimeter cube is prepared by dissolving a certain amount of COOH2 in water in a 250 decimeter cubed volumetary flask. Calculate the mass of COOH2 that is needed to prepare the standard solution. So we are actually looking for the mass of a COOH2. So what are we given? We are given the concentration and we are given the volume. So do I need to use Kavana in this reaction, in this activity? No, we don't use that formula. Why? Because we are not titrating yet. Okay, we are not titrating yet. So let's quickly collect the data. What do I have? I have the concentration of the acid, which is 0.20 mole per decimeter cubed. What else do I have? I have the volume, but my volume is in 250 centimeter cubed, is in incorrect SI units. What do I need to do? I divide that by 1,000. When you divide that by 1,000, you should get the concentration, the volume rather, as 0,2. You got it correct, ne? 0,2 decimeter cubed is the correct answer. Now that I have the concentration, I have the volume, I can calculate the number of moles. That is one of the tips that I gave you. So when we are doing stoichiometric calculations, what is the first thing that you need to do? Convert to number of moles when you are dealing with calculation. So what will be the number of moles? How do you do that? Let me quickly take it over here. So what are you going to do? You'll have C is equals to, which formula do you use? M over molar mass multiplied by the volume. Or you can use the formula C is equals to N over V. Find the number of moles. From the number of moles, go to the formula N is equals to M over molar mass to calculate the mass that will be produced, or that it will be needed rather, to prepare a standard solution. So let's go to this formula. How much is the concentration I'm given here? 0,20 is equals to, I'm looking for the mass of COOH2. All right. So what is the molar mass? You go to the periodic table, you look at what is the mass of carbon in the periodic table, you write the mass number for carbon should be 14, the mass number of oxygen is 16, and the mass number of oxygen is 16, and then the mass number of hydrogen is what? Is 1. And then you multiply those values by what? By 2 altogether. So you'll say 14 plus 16 plus 16 plus 1. Then the answer that you get, you multiply it by 2. I already did it for you. So I got 90. So the molar mass is 90. Then we say 90 multiplied by the volume that you have converted over there, which is 0,25. So that is 0,25. Then quickly punch into your calculator here. You just need to cross multiply. When you cross multiply it correctly and you punched in your calculator, how much do we get, guys? Of course, we also get 4,5 grams of what? Of COOH squared. Okay, so that will be the mass that will be needed to prepare the standard. So as you can see, guys, this is how you need to play around your stoichiometric calculations in this chapter. This is how you're going to mark yourself. If you said diprotic, you give yourself 1 mark. You have identified the bases, which is H2O and COO2, 2 minus. If you got it correct, you get another mark for that one. You get another mark for indicating which one is an ampholyte, and then by giving a reason that it acts as a base in reaction 1 and acts as an acid in reaction 2, you get another mark. And then here they were asking you to define a weak acid. We said that it ionizes or it dissociates incompletely rather, in aqueous solution. Then you get 1 mark. So option 1 is the one that I just did with you. Option 2, you can just take the concentration and then convert to number of moles, and then you should get the number of moles as 0,05 mole. Then you use the formula N is equals to M over molar mass. You substitute the number of moles, which is that 0,05 over here. Then you calculate your molar mass from your periodic table. Then you cross multiply. You should get the answer, which is the same, which is 4,5 grams. All right, guys, now let's quickly look at 3.4. All right, we just did 3.3 together. Let's quickly look at 3.4. 3.4 says to us, during a titration, 25 centimeter cubed of the standard solution of COOH, which is the oxalic acid, is prepared in question 3.3, which is that question. That's why I put it there so that we can be able to refer to it. Is neutralized by sodium hydroxide solution in the burette. And the balanced chemical equation for the reaction is that here the examiner gave you a balanced chemical reaction. Then they say to you the diagrams below, they show the burette readings before the titration commenced and at the end point respectively. As you can see here, we have before titration, and here we have at the end point. Now, it's very important that we know how to read the measurements on the burette. Remember, I said to you that this is the experiment that you must know and familiarize rather yourself with, which is titration. You need to know the apparatus that are involved. You need to know how to carry out the investigation or the experiment. So now we are given the readings of the titration on the before the titration, the burette readings. Here I have, they say that is the level of sodium hydroxide. As you can see here, I have 2. And if I count my spaces correctly, this is 1, 2, 3, 4, 5. That means my spaces, they will carry 2 each. Okay, so that will be 2, 2.2, 2.4, 2.6, 2.8, and then that is 3. So if we measure it correctly, this here, the reading over here will be 2.8 centimeter cubed. That is the level of sodium hydroxide before titration. After titration, after we have reached the end point, remember end point, this is when the indicator changes color. So we know that we have reached the end point. During the end point, we can see that now the level of sodium hydroxide has done what? Has increased. Again, we can see here is 3.8. If I go down, that will be 3.8,2. That will be 3.8,4, 6, and 8. So this will be 38.8 measurements, which is the level of sodium hydroxide at the end point. Okay, so now let us see how this information is going to assist us, right? Then they say use the burette reading and calculate the concentration of sodium hydroxide solution, right? Remember, guys, I said the moment you see the word titration, neutralization, end point, equivalent point, all those words, you know that which formula do you use? The Kavana formula, which is CAVA. VA is equals to NA, and then over CB VB over NB. So remember, A is the acid and B is the base. Now let's quickly read the information that we are given and see if we can substitute. Now let's see. Here we are given the volume of the acid. During titration, we have 25 centimeter cubed of the standard of the oxalic acid. We have the volume of the acid. The volume of the acid over here, let me quickly use a different color. The volume of the acid over here, we are given as 25 centimeter cubed. I've indicated to you previously that in this formula, we don't really need to convert to decimeter cubed, especially if your volume is in the same units. So as you can see, our volume before and after is in the same units, so I don't really need to convert. So here, what do I have? In the place of the volume of the acid, I'm going to put the 25. All right, 25, and then prepared in question 3.3 is neutralized by a sodium hydroxide solution in the burette, and then the sodium hydroxide solution, what do we have there? We have the volume of sodium hydroxide. What will be the volume of sodium hydroxide? We will have to say the volume at the end point minus the volume before the titration. So that means we will say 38.8 minus the 2.8. We should get the volume of sodium hydroxide that was used for titration. And if you did it, the calculation correctly, how much do you get? Yes, I get 36 centimeter cubed. Okay, so the volume of the base will be 36. So this is the 36 that we use the one that was used during the titration, during the process. All right, then what else do we have? We have the concentration of the acid, which is 0.2 from the previous question, which is 3.3. As they said, we must refer to it. So that will be 0.20 over there multiplied by 25. And what am I calculating? I'm calculating the concentration of sodium hydroxide. Sodium hydroxide is a base, so I'm looking for the concentration of the base is equals to, what am I looking for? I'm looking for the ratio between sodium hydroxide and oxalic acid. The ratio of the acid is 1, as you can see from the balanced equation, and the ratio of the acid of the base rather is 2, which is the sodium hydroxide. The ratio is 2 over there. So that will be 1:2. And then quickly punch into your calculator, and then let's see how much do we land rather as our concentration of the sodium hydroxide, or the concentration of the base. If you have done it correctly, your answer should be 0.28 moles per decimeter cubed. So that is the correct answer for the question. I hope you guys got it correct, and most of you got it correct. So there it is. That is the other way. This is the way that I've done it. I did this with you, okay? And then the other way you could have done it is to calculate the number of moles of the oxalic acid, and then from there, but you do not forget to convert that 25 centimeter cubed, you convert it into a decimeter cubed by dividing it by 1,000. Okay, that's why they got 0.02, and then you punch into the calculator, you get the number of moles as 0.005. Then from there you go to the mole ratio between sodium hydroxide as well as the oxalic acid. The ratio is 1:2. Then that's why the number of moles of sodium hydroxide will be 0.01. Then you go back to the formula of concentration. Then you include the concentration of sodium hydroxide as well as the number of moles of sodium hydroxide. I mean, you calculate the concentration of sodium hydroxide using the number of moles of sodium hydroxide as well as the volume of sodium hydroxide, which volume, that 38.8 minus the 2.8 that we saw on the readings of the burette. I hope you guys got the same answer and you understand how do we use titration to get the correct answer. Now let us look at the last exam question that we are going to be doing together. The last exam question, the other one, you're going to do it as a homework at home. I think we have covered a lot of exam activities. Now you know how the examiner is structuring the exam questions when we are dealing with this topic. Now let us quickly look at question 9. Question 9 says the Ka values for two acids, oxalic acid and carbonic acid, are as follows. You have the oxalic acid as well as the carbonic acid. As you can see that you have the Ka values over there. Then let's quickly go to 9.1. 9.1 says to us, define the term weak acid. Guys, I hope you now know how to define it. We've been defining it so many times already. We already know that it ionizes incompletely in aqueous solution. Right. 9.2 says to us, which acid, oxalic acid or carbonic acid, is stronger? Give a reason for your answer. Where do we go? We go to the Ka values. We see that oxalic acid is 5.6 times 10 to the power negative 2. What does that mean? It has a higher Kc value. The higher the Kc value, the stronger the acid. So the correct answer here will be oxalic acid. So the correct answer will be oxalic acid. Why? It has a higher Ka value. All right. The higher the Ka value, the stronger the acid. All right. I hope you remember that. 9.3 says oxalic acid ionizes in water to form that formula. There is our formula of oxalic acid. They say write down the formula of two bases in this reaction. You already know that the bases are going to be H2O as well as COO 2 into 2 minus. All right, those are the bases because COOH2 will donate a hydrogen there, and then that will make H2O a base, and that will make COO2 minus a base in the reverse reaction when hydronium ions has to donate back the hydrogen. All right, that is why these two are the ones that are our bases. 9.3 says learners prepare a 2 decimeter cubed of what? Of sodium hydroxide solution of a concentration of 0.1 mole per decimeter cubed. Calculate the pH of the solution. So how do we calculate the pH of the solution? What is the first thing that we need to do? We first need to calculate the concentration, isn't it? What are we given? We are given the volume of sodium hydroxide. We are also given the concentration of sodium hydroxide. All right. So the first thing that we are going to do is to go to Kw. Kw is equal to the concentration of hydronium ions okay, multiplied by the concentration of OH minus, remember. Now remember, the value of Kw is 1 times 10 to the power negative 14 is equals to the concentration of hydronium ions. Okay, remember we are calculating the pH. That's why I am trying to get the concentration of hydronium ions using this one, because we have the concentration of what? Of sodium hydroxide. The concentration of sodium hydroxide will be equivalent to the concentration of OH minus, which is 0,1. 0,1. Then you do your mathematics. When you did the maths correctly, you solve for the concentration of hydronium ion, the hydronium ions. I hope you got the correct answer. How much did we get, guys? Yes, I got 1 times 10 to the power negative 13 mole per decimeter cubed. Okay, now that I have the concentration of hydronium ion, I can quickly go to the pH. It's easy now. Then I just go to pH is equals to minus log into the concentration of hydronium ion. Okay, once I've done that, then I can say minus log. Then you substitute the concentration of hydronium ion, which is what you calculated over there, which will be 1 times 10 to the power negative 13. And the pH will be 13 if you calculated it correctly in your calculator. Now, as you can see that the pH 13 is next to 14, that indicates that the pH is greater than 7 towards 14. This means that this is a very basic solution. Why is it basic? We have a strong base reacting with a weak acid. All right, so this is a fully basic solution. Let's quickly move on to the last part of the question, which is 9.5. It says during titration of the sodium hydroxide solution in question 9.4, dilute oxalic acid, the learners find that there is 21.5 centimeter cubed of sodium hydroxide. It neutralizes exactly 14.2 centimeter cubed of the acid, the oxalic acid. The balanced equation for the reaction is there. There is the balanced equation. Then they say calculate the concentration of the oxalic acid. Okay, calculating the concentration of the oxalic acid, again, what do you use? The moment you see titration, you see neutralization, which formula must you use? The Kavanaugh, which is CaVa is equals to Na over Cb Vb over Nb. Then you just quickly substitute. You are looking for the concentration of the acid. You are given the volume of the acid, which is 14.2. Okay, there it is. The volume of the acid is 14.2. And then we have also the concentration of the base, which is 0.1 from the previous question. And then we multiply that by the concentration of the base, which is 25.1. As we said, that there's no need for you to change the concentration, rather the volume, into decimeter cubed, because it will still give you the same answer. You are dealing with the same SI unit. Then the ratio between the acid and the base is 1:2, 1:2, and then you just quickly punch into the calculator. If you have done it correctly, you must get 0.09 mole per decimeter cubed. All right. Well done, guys. I hope you guys now know how to deal with this formula. We have done it so many times now. Let's look at the next question. It says the following indicators are available for titration. We have indicator A, B, and C over there. We look at their pH ranges. They are going to tell us which indicator we can use. Now, remember here, we have a 3.1 to 4.4. This tells you that the solution here is acidic. Okay, and then between 6.0 and 7.6, that tells you this is a more neutral solution. And then 8.3 to 10, that tells you that the solution is basic. How do we get an acidic solution? We are normally going to react a strong acid with a weak base. And when we react a strong acid with a weak base, we are going to get an acidic solution. And the type of indicator that we are going to use is methyl orange. Methyl orange. Okay, that is for an acidic solution. For a neutral solution here, we have a strong acid with a strong base. The correct indicator that we are going to use is the thymol blue. Okay, that is the correct indicator to use for a neutral solution. For a more basic solution, that means we have reacted a strong base with a weak acid, we are going to use a phenolphthalein. Okay, that is the correct indicator to use. Now, let's quickly look at 9.5.2. It says, which one of the indicators above is more suitable for this titration? Give a reason for your answer. For this titration, we have reacted a weak acid, okay, with a strong base. So a weak acid with a strong base, what type of indicator we are going to use? We are going to use a phenolphthalein. Okay, why phenolphthalein? Because we have a strong base with a weak acid. So the correct answer there will be phenolphthalein. Why are we using this one? Because we have reacted a strong base and a weak acid. Okay, weak acid. That is why that one is the correct answer. Guys, we have come to the end of our activities. We have done so many activities together. This is just some solution that I put for you. You can just go through them at your own time to see how best you could have answered the question and how the examiner is going to mark you. All right. Now that we have done all our examination questions together, this one is your own homework to try and do it at home. So quickly take a screenshot of this activity and try to do it on your own. Now that you have taken the screenshot, let us look at the summary of our lesson. Remember, we said that you need to know under acids and bases. We need to know definitions of acids and definition of bases in terms of two theories, Arrhenius and Lowry. We also spoke about strong acids, strong bases, weak acids, and weak bases. You need to know which one is a strong acid, which one is a strong base, and which ones are weak acids and weak bases. We also looked at the differences between concentrators versus diluted. We looked at some titration calculations where we were doing stoichiometry calculations. We also looked at some neutralization reactions where we were looking at common laboratory acids and bases. We've spoken about hydrolysis. We said that is the reaction of salt with water. We did some pH scale, or we spoke about some pH scale, and we also did some pH calculations. We looked at conjugate acid-base pairs, and then this is just the summary of the chapter that we have done together. Now, preview of our lesson, what did we do? We looked at the structure of the question paper. We did say that you will see a multiple choice, you'll see some definitions, you'll see some stoichiometry calculations in this section, you'll see some pH calculations also. What do? You just convert to number of moles. We looked at some action verbs to say if the examiner says define, identify, explain, what is it that the examiner is actually asking from you. We looked at mind map. We said that it would be advisable for you to use mind maps to help you structure your lesson, or when you study, you know which topics to look at. We looked at some common errors and some misconceptions that you are going to have in this chapter and how to handle them. We looked at the use of a formula sheet as to how do we use a formula sheet. And then lastly, for this topic, please ensure that you bring your own calculator and you familiarize yourself as to how to use a calculator. All right, guys, thank you so much for tuning in today's lesson. I hope you learned a lot on acids and bases. Now it's time to go back home and try to do it on your own. My name is still Dimpo Arampora, and thank you so much for tuning in.